First, relative lowering of vapor pressure, that we already done. Second, elevation in boiling point, that is the topic of today. Third is your depression in freezing point, and last one is your osmosis. So we'll take up today elevation in boiling point. Let us start with a graph. Here we are plotting vapor pressure. Here we are plotting temperature. And class, as you know, that vapor pressure is directly proportional to temperature. So if you increase the temperature, vapor pressure always goes on increasing, so the graph becomes like this. So this is the graph, this is the curve for your solvent. And the topic is boiling point. So we know that boiling point, what is the temperature? It is the temperature at which vapor pressure of liquid becomes equal to atmospheric pressure. So if it reaches 1 atm pressure, that is your 1 atm, then that corresponds to TB0. So what is TB0? TB0 is your original boiling point. And now we are going to add non-volatile solute to it. And class, you all know that if you add non-volatile solute to any given liquid, the vapor pressure of solution always decreases. So this was the curve for the pure solvent. Now if we are going to add non-volatile solute to it, vapor pressure of solution will decrease, and now you will get a curve like this. But previously this was the boiling temperature, and now since it is achieving 1 atm here, so therefore boiling point always increases when we put non-volatile solute in a given liquid. So this is a curve for your solution. So class, if we subtract this minus this, we get delta TB. And what that is, delta TB is your elevation in boiling point. Here is your final boiling point. So hence, if we subtract TB0 from TBF, we get delta TB, and delta TB is your elevation in boiling point. And class, it was also found experimentally that delta TB is directly proportional to molarity. More the amount of solute added, more number of solute particles will be on the surface of the liquid, and you all know vapor pressure is the surface area. Since surface area will decrease, therefore boiling point will be elevated more and more. So hence, more the number of solute added, more the elevation in boiling point. Now class, the next step, we'll just open it. That will give me delta TB equal to Kv into M. So what is Kv? Kv is your constant of proportionality. Constant of proportionality. And M, you know, molarity. And Kv is also called molar elevation constant. Molar elevation constant. One more name to it, ebuloscopic constant. Ebuloscopic constant. In class, if you put M equals to 1, if molarity equals to 1, then you get delta TB equal to Kv. So class, how can you define molar elevation constant? So molar elevation constant is the elevation in boiling point when molarity of the solution is unity. And class, let us make equation number 1, and now just open the equation number 1, we get delta TB equals to Kv, and then I am going to write expression of molarity Wv into 1000 upon Mv into Wv. So class, this becomes our expression for elevation in boiling point. And we'll be doing numerical on this formula. Do numerical on this formula. Take our register, write out this numerical. Find elevation in boiling point when 18 gram glucose, molecular weight 180, is dissolved in 100 gram solution. If KBH2O equals to 5.12 Kelvin kilogram mole inverse. So class, we are supposed to find out what amount of temperature will be elevated when we put 18 gram glucose in 100 gram solution, or rather we can call it 100 gram H2O. So we use this formula, delta TV equals to kV into WV into 1000 upon mV into WA. This we are supposed to find out. kV has been given 5.12. Weight of solute 18 gram multiplied by 1000 upon molar mass of glucose is 180. Weight of solvent is 100. Let's correct. This gives us 10. This gives us 10. 10 by 10 gives to 1. So delta TV equals to 5.12. So this way you can solve this number. Now write down your homework. I am going to give you 2 more numerical. You solve it at your home. Find elevation in boiling point when 6 gram urea, molecular weight 60, is dissolved in 50 gram H2O. Given KBH2O, again the same value 5.12 Kelvin kilogram mole inverse. Second numerical which you will be solving is a little bit typical. Find boiling point in degree centigrade and in Kelvin when 68.4 grams sucrose, molar mass 342, is added in 200 gram H2O, given KBH2O, the same value again 5.12 Kelvin kilogram mole inverse. So we have taken 2 colligative properties. First, relative lowering of air pressure, that was taught in your class. Second, elevation in boiling point, which you have just completed now. So class, these 2 numericals are for your homework. To complete it, we will meet tomorrow